In the previous class, we saw hub, and the hub has got a logical bus in it. And this logical bus provides only one broadcast domain and one collision domain. As a result, correct. As a result, all the traffics will be flooded, broadcasted to everyone. Every device that is connected to the hub will receive a packet sent by each computer, which is not safe. First thing is safety. It's not safe because everyone is going to see your message, though you didn't send to everyone. Secondly, it is going to create collusion. As a result, we saw only 8 ports are allowed in a hub. Now we are going to learn next device called bridge. This bridge is an intelligent device. That's the very first word I'm saying. It's a smart device. When I say smart device, don't compare this to your cell phone. Yeah, your cell phones are more smarter. This we call it a smart device or intelligent device. The reason is compared to hub, this is smarter. Compared to hub, this is smarter. What do I mean by that? Hub don't learn MAC address, but this learns MAC address. MAC address is layer 2, which means switch or a bridge is a layer 2 device. It's a layer 2 device. All these ports will learn the MAC address of the connected device. Each port will learn the MAC address of the connected device. So when you have a device here with the MAC address, what is the size of MAC address? 48 binary bit size. 48 bit size. So now bridges can learn MAC address. Learns MAC address. Bridges can learn MAC address. That is why it is a smart device. It's an intelligent device. That is why we call it as layer 2 device. Because this address, MAC address, works in layer 2 of OSI. Layer 2 of. Alright, we are going to see that OSI one more time later. The reason why I gave you an introduction to OSI is when we talk about layer 2 device, you should know that we are talking about OSI layer 2. That is why. So there's a separate session will be there for OSI a bit later. Now next is, because it is learning MAC address, we have more collusion domain. Yes, for example, if this bridge has got, let's say, 12 ports, each port got a collision domain. So you got 12 collision domain, 12 collision controller. I just use the word controller to make you understand what the word domain means. Domain. It's nothing but controller. And again, only one broadcast domain. Only one broadcast domain and 12 collision domain. So this 12 collision domain. How? Because each port can learn MAC address. Each port can learn MAC address They can control the collision. I told you the word domain here means controller. Because they learn MAC address, because the bridges learn MAC address, bridges know which MAC address device is connected on which port. So there is no need for flooding here. Bridges can forward the packet straight to the destination. For example, let's say I have a computer, sorry, a bridge connected to a computer called A. Another device, B. Another device, C. D. And let us assume the MAC address of A as AAA, BBB, CCC, and DDD. Just take it as MAC address. Usually MAC address is what size? 48-bit size. I don't want to write that 48-bit, it will be too big, so I'm making it simple. B, BBB, CCC, DDD. Now these MAC addresses are learned by the bridge. Hub never do this. So the bridge knows that there is someone called A connected to this port. Let's say this port number is 1, 2, 3, 4. It knows that to the port 1, A is connected, BBB is connected to port number 2, CCC is connected to port number 3, DDD is connected to port number 4. The bridge knows who is connected where. So it no need to broadcast, you see. If A wants to talk, to C, the traffic will go straight to this port. Yeah, traffic goes like this, and it refers the table. It knows that C is connected on 3, so it forwards the packet out on port number 3. Is there need for flooding here? Is there need for broadcasting? No. So collision is avoided here. If everyone is always broadcasting, then only collision occurs. Here there is no collision because each port on the bridge learns MAC address. Because they learn MAC address, because each port on the bridge learns MAC address, they don't broadcast. As a result, they avoid collision. That is why if it is 12 port, we say 12 collision domain, because the learning of MAC address on each port controls the collision. Do you agree? Okay. Each port on a bridge learns MAC address, which prevents collision. How? Because we need not to flood, we need not to broadcast. We don't use the common bus topology to forward the traffic. We have a dedicated path to go to C. Because the switch knows that if traffic is coming from A and it wants to go to C, the traffic need to be sent to port number 3. As a result, it is not using the bus topology. You see, this device also got bus topology, and it also creates a unique path for each destination. It has got a unique path. So there is no flooding all the time. There is no broadcast all the time. So when will this backbone link bus will be used? If a packet wants to go to E, is there any information about E in the table? No. When there is no info about the destination, Only then the traffic will go to the backbone and it will try to discover E. See, I repeat, when the destination is unknown, it uses that one common backbone. That's why we have one broadcast domain. Only one common backbone to connect to everyone. If the destination is known, will it broadcast? Yeah. When the destination is known, will it broadcast? Will it broadcast or not if the destination is known? If it is unknown only, it will broadcast. If it is known, it will do unicast, isn't it? It sends right to the port because it knows the destination. Agree? When the destination is known, it will not broadcast. It won't broadcast. Correct? Okay, be clear in this. Bridges will broadcast only if destination is unknown. All right? You need to write this line. Bridges will broadcast the traffic only if the destination to the traffic is unknown. Only if the destination to the packet is unknown. Okay? So can a bridge broadcast? Yes, it can broadcast. It has got that common backbone to broadcast, and it can also do unicast after learning the MAC address of the connected device. Because it learns the MAC address and forwards the packet based on the MAC address, because the decision to forward on a port is taken based on the MAC address, bridge is called as layer 2 device. Do you understand bridge? Okay. If you want to write something from here, you can write. All right. I'm trying to explain you. Bridge is a software-based device. Bridge has got a box, physical box. It has got motherboard. It has got RAM. It has got CPU. It has got ports. It has got everything like your laptop. In your laptop, what makes all the work? It is the operating system. Am I right? In your laptop, all the decisions are made by the operating system that you are running. It may be Windows or Linux. That is why it is called a software-based device. Your laptop is also a software-based device. Your computer, your cell phone, they're all software-based device. If that software is removed, the computer can't work. It cannot work. Every computing job is carried out by the operating system. Likewise, Bridge also has got only one operating system to do every job. That is why it is software-based device. Do we have a hardware-based device? Yes, we do. That comes next. This is a software-based device. Bridge is a software-based device. So now we are moving on to the next topic. See, I'm copying the same thing. I'm copying the same thing and pasting it again. Only thing I will change is the title and then this one. Switch. Switch is also a smart device. It learns MAC address. It's a layer 2 device. But switch is a hardware-based device. What does it really means? See, switch also got operating system, like your laptop. Like bridge, switch also got the physical box, the ports, the operating system. Additionally, switch has got more ASIC in it. This ASIC is a chip. This is like a mini processors. So switches got more ASIC chips. As a result, switches can handle more amount of traffic than a bridge. Switches have got this additional hardware called ASIC. As a result, switches can handle more amount of traffic because the switches are not only having the processor, they also have a lot of ASIC chip, which is like a mini processor. See, if only one person is building a house, it will be difficult. It won't be easy for him to finish the house sooner. It will take a long time. But when there are a lot of helpers to build a house, then house can be built much earlier, faster, easy. The builder can build a house if he has got more helpers. That is what here you see in switch. Switch has got more helper. ASIC chips are the helpers. So switches can have more ports. Switches even have got 96 ports. Then you have 96 collision domain. Each port is a collision domain because each port on a switch can learn what it can learn. Each port on a switch can learn what? MAC address. MAC address. No? Same like bridge. Everything is same like bridge except this one. What? This is a hardware-based device. And you see this table where the MAC addresses are learned are called as MAC table. MAC address table. It's a MAC address table. Both bridge and switch are layer 2 device, but there is only one difference. What is that? Correct. Switch is a hardware-based device. Bridge is a software-based device. Now we have one more device to learn called router. What is the function of a router? Router is to connect devices of multiple network. For example, 10.0.0.1 10.0.0.2 10.0.0.3. You see, these three devices belong to same network. You see, 10.0.0, here also 10.0.0, here also 10.0.0. This PC is identified with the number 1. This PC is identified with number 2. This PC is identified with number 3. Likewise, let's say I have another switch. This is how we draw switch. I have another switch where I have computers like with IP address like 20.0.0.3, 20.0.0.2, 20.0.0.1. You see, we have two different networks. What are they? Priya, are you listening? We have two different networks. What are they? No. There are two different networks here. What are they? 10, 10, no. Yeah, correct. You should not say one. One is not a network. This whole thing is called 10 network. Okay, this is 20 network. So we have 10 network and 20 network. You see, what is router? The device helps to connect the devices which are in multiple networks. Router helps to connect devices of multiple network, devices that are in different networks. Let me write it in a simple way. Devices that are in that are in different network. Devices that are in different network. Routers help to connect devices that are in different networks. See here, we have a router. In between, this is how we draw a router. And this port will have 10.0.0.4. This is the IP, but the network is 10. Likewise, this port will have 20.0.0.4. Why I'm using 4? Because 4 is what I didn't use. I have already used 1, 2, 3 to identify those 3 computers. So I'm writing here the host. Right? So what is a router? Router is a device that helps to connect the devices that are in different network. Whereas the bridge, the hub, the switches, they don't do this. They only help to connect devices that are in same network. All the above, except router, all the above that you learn, they support only to connect devices that are in same network. You see, this is in same network. You have switch. You don't need a router. To communicate between this port to this PC, between these 4 devices to communicate. 1, 2, 3, 4. They are in same network. So you need only a switch or a bridge or a hub. Likewise here to communicate within this green area. Within this green area, only a switch is needed. But if you wish to communicate between this one and this one, then you need a router. Without a router, reaching between one network to another network is not possible. You understand? Okay. So let us start from the beginning. The devices, first we learned, the other day we learned amplifier. But the problem with the amplifier is it even amplifies the noise. So came bridges. Bridges are better than amplifier. Bridges were only amplifying or regenerating only the data, only the actual signal. So that's the good thing about bridge. But the problem with bridge is it is having only 2 ports. So hub was discovered. Hub is a multi-port repeater. Hub is a multi-port repeater. So first we saw amplifier, then we saw a repeater. A repeater regenerates only the data. And then we saw hub. Hub is a multi-port repeater. But the problem with the hub is it has got only one collision domain. So yeah, only one broadcast domain and one collision domain. So you cannot have too many devices connected. That is why the port is limited to 8. And then came an intelligent device called Bridge. Bridge learns MAC address. As a result, there is no need for broadcasting every time. That is how we avoid collision. So each port has got a collision domain. If I have a 48 port switch, I'll have if I have 48 port bridge, I'll have 48 collision domain. But bridges don't have too many ports like a switch. Switches have got the hardware, additional hardware called ASIC. As a result, you can have switches of various size. Some are 48, some are 96, some are 100 port, some are 200. Even I have seen 300 port switch. So switches can handle more traffic because they have lot of ASIC chip. Whereas bridge has got only one CPU and one operating system to take care of everything. As a result, bridge cannot support too much traffic. It cannot support. We call bridge as software-based device. The reason is it is the only operating system responsible for all the functions of the bridge. Whereas in the switches, we have ASIC to share the load. Okay, how many collision domain and 96 port switch have got? How exactly 96 collision domain and one broadcast domain. Now, about the routers, each port will have a collision domain. In that case, the routers in this router I have, let's say, 1, 2, 3, and 4 port. Let's say I have 4 port. Then I will have 4 collision domain and also 4 broadcast domain. What does that mean? When a broadcast comes, it goes everywhere, but it will not pass through the router. It will not pass through. It controls the broadcast. Every port on a router controls the broadcast. So each port on a router has got one collision domain and one broadcast domain. Do not forget. Each port on a router has got one collision domain and one broadcast domain. If I have 3 port in a router, how many collision domain? How many broadcast domain? Okay. Now I'm going to draw a diagram. Try to answer this. I have a switch 24 port connected to another switch of 24 port. What will be the number of collision domain in total and number of broadcast domain in total? I'll tell you the answer. I'll tell you the answer. You see 24 port here, 24 port here, totally 48 port. But this particular port is connecting back to back. So it is only 47 because this is shared one. This port, you cannot take it as one collision domain. So here it is 23, here it is 23 and plus 1. So it is going to be 47. It's not 48. Okay, this is one collision domain, one whole thing. Nextly, bus topology is what the broadcast domain. Here you have one common bus, and here you have one common bus for all the ports, all 24 ports. But that bus is connected like this, no? When a broadcast is sent, it will be sent to everyone, all 47 ports. So how many broadcast domain we have here? No? It's only one. You should not say two. When you connect two switches together, the broadcast gets merged. It becomes a bigger broadcast. Earlier it was only one switch. So broadcast domain was only for 24 port, only one broadcast domain. But when I connect this wire, this port to this port, the broadcast domain get extended to here. So the broadcast domain is again only one. You okay with this? Very clear? Okay, then you're going to answer this question. Again, I have 24 port switch. It's a switch connecting to a hub. Hub of 8 ports, let's say 8 ports. Now tell me how many collision domain we have and how many broadcast domain we have. How many collision domain we'll have and how many broadcast domain we'll have. Listen, Priya, this is hub. Hub has got only one collision domain, remember? Uh, and then that one also here, you see it is shared. So it is 23 plus 8 or 24 plus 7. That is how it should go, okay? 24 plus, this one is shared, Uh, so if you take 24, then it goes up to here, up including this port. So you have remaining 7 ports here. Totally 8 ports. So one is already shared there. 24 plus 7, which is 31. Sorry, yeah, 31 collision domain. How many broadcast domain do you think? Really? Wow. Sorry, then I didn't hear you well. I appreciate it. Great. Good job. Now tell me how many broadcast domain we have. How many broadcast domain we have in total? No. In the previous case, I told you when we connect two switches, the broadcast becomes bigger. Same way, here also the broadcast is becoming bigger. It's only single broadcast domain. It becomes bigger. It get merged, okay? It's only one. Even if I have 100 switches connected, 100 switches connected like this, how many broadcast domain you will have, Only one. You understood? Okay. In the same